LeetCode Problem 2. Add two numbers. Hey everyone, this is Keystrokes. Welcome back to the channel. Today we'll be solving LeetCode Problem number 2, which is about adding two numbers represented by a linked list. LeetCode ranks this problem as medium, so let's dive right into it. So let's take a look at the problem statement. It says that we are given two non-empty linked lists and they represent two non-negative numbers. The digits are stored in reverse order and that each of the nodes will contain a single digit. And our goal is to add these two numbers and then return a new linked list which will represent the sum of these two numbers. And there are some assumptions, like the numbers do not contain any leading zeros, except if the number is 0 itself. The first example they have here is adding the number 342, which is represented in reverse as 2, 4, and 3. So this is our first linked list. Then our second number is 465, which is now represented in reverse as 5, 6, and 4. Now when we add these two numbers, the answer is 807, which is again represented in the reverse order right here, which is 7, 0, and 8. And you can see the input here is the first linked list, which is 243, linked list 2, which is 5, 6, and 4, and our output should be 7, 0, and 8, and they explain that adding the two numbers gives you 807. And there's another example with linked list 1 having one node which is 0, linked list 2 with another node having 0, and addition of 0 and 0 is a 0. So let's see what all concepts we need to know to solve this problem. The first one is simple basic programming concepts. In this case, it will mostly be loops. Then as for data structures, we'll need to know how to operate and work on a linked list. This should be a pretty simple one, which should require simple math. And if you like more such solutions, don't forget to subscribe to the channel and like this video if you like the algorithm that we are going to discuss. Okay, so now let's solve this problem. Okay, so we'll be given two linked lists and we can use the examples we saw in the problem statement. So the number in the example was 342 to be added with 465, which should add up to 807. So as an input to our program, we'll be given this number in the reverse order as a linked list. So that will make it as 2, 4, and 3. And this will become our linked list 1. And then the second number will be given to us as 5, 6, and 4, which will be our linked list second. So now in normal math, if we had to add these two numbers, how will we do it? Let's see. So first we'll add 5 and 2, which will give us 7. Then we'll add 4 and 6, which will give us 10. And 1 will be carryover. Write it as plus 1 here. And then we'll add 4 plus 3 plus 1, which will be 8. And we get the same answer. So we need to start from the rightmost character of the numbers, start adding them, keep a track of the carry if the sum is over 9, and then just keep adding those numbers. So we are already given these numbers as linked list. In the right order, how we'll add it? Because the numbers are reversed, that means the first nodes always represent the rightmost character, which is 2 and 5. Now, if we add them, we get 7, and we can create a node out of it in a new linked list. So now when we add 6 and 4, our value becomes 10. Now because this number is greater than 9, we find the remainder of this number when we divide it by 10. In this case, the remainder will become 0. So in this new node, we'll only store 0. And we'll point 7 to this new node that we created that stores 0. Now because this number was 10, we know that we need to have a carryover when we add the next digits. So we'll have a plus 1 here as the carry. So now when we add 4 and 3, our sum is 7, but when we add this plus 1 as well, our sum becomes 8. And then we'll create a new node, store 8 in there, and point 0 node to this 8. And this will be our linked list, which is our output. If you see, the number is 708, which is written in reverse of the actual sum, which is 8, 0, and 7. And that's our answer. So let's take another example. What if the number was 1, 2, 3, and we had to add 9 and 8 to it? Now when we actually add these numbers, we start on the rightmost, which is 8 plus 3, which is 11. We have 1 as carryover. 9 plus 2 will be 11. Adding 1 carryover will be 12. And then we have 1 carryover again. And then we have 1 carryover again. Adding that to 1, we get 2. So our final result should be 2, 2, 1. Now in this case, if you notice, only the first number had 3 digits and the next one did not. So in this case, the linked list that should be given to us should look like 3, 2, and 1. And the second linked list should be 8 and 9. Now when we create our new linked list, we add 8 and 3, we get 11. And because 11 is more than 9, we find the remainder when we divide it by 10. So 11 becomes 1. We store that in a node. And then we have a carryover of plus 1. Now when we add 9 and 2, it's 11. We add the carryover, which is 12. Now again, this is greater than 10. So we find the remainder when we divide it by 10. And we get 2 as the remainder. We store that in a new node and discard this 12. And then point 1 to 2. And because we had a carryover, we'll again have a plus 1 here. And now when we add plus 1 carryover to this 1, we get 2 as the next digit that we need. And we point the previous 2 node to this new 2 node. And that becomes our sum again. And we can see we have 2, 2, 1, which is the same number as here. And I just want to cover one final example, which is 99 adding 5. Now in this case, 9 plus 5 is 14. So we put 4 here and we have a carry here. Now adding 9 plus 1, it's 10. And because we don't have another digit, this just becomes 104. Now how will this work? So our first linked list will be 9 and 9. And our second linked list will be just the node 5. We have 9 plus 5, which is 14. We find the remainder when dividing by 10, which gives us 4, and we store that in our node. And then we have plus 1 as the carryover. Now we add this 9 to this carryover, and we get 10 as the answer. Now because 10 is greater than 9, we find the remainder when we divide 10 by 10, which is 0. So we create a node with 0 as a value and point 4 to 0. And we still have plus 1 as the carryover from the previous 10. And now because there's no other digit to add, we just add 1 to no other digit and put that in a node and point 0 to this 1. And our answer then becomes 104, which is what we calculated right here. So this is an interesting corner case when all you have is a carry and all the digits have been exhausted from the 2 linked lists that were given to us. Okay, so as we saw, it's as simple as adding each node of the linked list as normal math, and you'll get your answer. Here we have the pseudocode that we're going to implement. I'm not going to discuss the pseudocode right now because this is what we are going to implement. So it's coding time. Okay, so here I have IntelliJ and I've copied over whatever LeetCode gives us. The first thing they give us is a list node, which you can see as comments in the question. And then they have a solution class and a add2numbers method, which takes in 2 linked lists, L1 and L2. And that's what I have right here. This is the list node class, which is the individual nodes of our linked list. And then we have a solution class with add2numbers as the member function. So to start with this, let's create a pointer that tracks where we are currently in each of these nodes. So for that, we'll need list node, let's say current L1, and point it to L1 itself, which will be the first node in L1 linked list. Then we create another node that points to the current node in linked list 2. Let's call it current L2. And then we'll have another variable that will track the carryovers that we have as we add the individual digits. Okay, so now let's run a loop until our current L1 is not null or L2 is not null. Oops, let me fix some of those issues. Perfect. So we basically keep iterating until both the lists are exhausted. So now we need to read the value from each list at the position we are. So let's store our first value in L1 value variable. Now there's a possibility that current L1 could be null because this loop will keep going until both of them become null. So if current L1 is not null, then we read its value, which will be current L1 val. Otherwise, we just read 0. Oops, let me fix the ternary operator here. Similarly, for the second linked list, we store that in L2 value. If current L2 is not equal to null, then we read the value from L2. Otherwise, we assume the value is 0. Now let's calculate the sum for our new node, which will be L1 value plus L2 value, and if we have any carry. Right now we don't, but we might in the future. Now this sum could be greater than 9. If that's the case, we'll have to introduce a new carry, which will be carryover, and we can add a simple condition. If sum is greater than or equal to 10, then our carry basically becomes 1. Otherwise, there's no carry from this addition. And then we do a remainder on the sum. Okay, and now that our nodes are added, we move on to the next node in each of these linked lists. So to do that, we update our current L1 to be next if current L1 was not null. So if current L1 is not null, then we move on to the next node. Otherwise, we keep current L1 as null. We do same thing for L2. Now we have calculated the sum, but we haven't added the sum to the linked list that will return. In fact, we haven't even declared the linked list that will return. Let me create a new linked list with a dummy head node. Let's call it new list node, and let's not give it any value. And then we should have another node that points to the current position in this dummy head node, and that's where we'll start appending our output. So because this dummy head node right now contains nothing, we can point it to itself. So we can name this as current output and point it to dummy head node itself. Now we have a new sum value here. So let's first create a new list node with this new sum value, and we should append it to the current node that we are pointing in our output linked list. Now that's represented by current output, so pointing its next to this new node that we created. And then we move our current output to point to the next node so that we can keep appending as we add more and more nodes from our input linked list. Now when both the linked lists are exhausted, there's a possibility that this carryover could still have a value. And by the way, I just noticed a bug here. This should not be 1, this should be 0, because we start with a 0 carryover. But going back, this carryover could be 1 when we come out of this while loop, just like the example we saw during brainstorming. To handle that, we can just add a very simple condition here. If carryover is greater than 0, then we'll just add a new node to our output, which will have a value of the carryover. And our output should be dummy node, but dummy node itself is just an empty dummy node that we created where we started to append our result. So in this case, it should be dot next, because that's pointing to the starting of our output. Creating this dummy head node is a very standard concept in linked list. And if you're not familiar with it, let me know and I can create a separate video where we talk about creating new linked list and all kinds of operations. I've configured the main class to have an example here from the problem statement in LeetCode. So let's try to run this program and see what our output is. So it says pass and the output is 708. So let's see what we added here. Let me switch to LeetCode real quick. So we had two numbers, 243 and 564, which added to 708, which we see in our output right here. Well, let's copy our program into LeetCode and see how it performs. So copying this whole method and replacing this right here. And let's run this code to make sure the base case passes. Okay, this was accepted. And now let's submit this and see if our solution is acceptable. This looks pretty good. Our solution was accepted and it's actually one of our fastest solutions. Okay, so that wasn't bad. If you know your linked list, if you know your basic math, this problem was pretty easy to solve. So if you like the algorithm and the way I explained it, please don't forget to like this video and to subscribe to my channel. I also have a Twitter account that you can follow, and more questions will be coming out soon. Thanks for joining in and keep solving those problems. Have a great day.